Alright, so today I'm going to be teaching you a lesson on stretching, compressing, and reflecting functions. This was the lesson that was gone over today. However, if you were absent, here's a nice quick video to recap what was discussed today. So as we know, yesterday we talked about translations of functions, where we talked about horizontally and vertically shifting functions up, down, left, and right. We paid attention to when the number inside the parentheses, whether it was plus or minus, and how that affected the shifting of the function. We also paid attention to the number outside the parentheses and how that impacted whether the function was vertically shifted upwards or downwards. So today what we're going to be starting off with is I have a do now question for you that I'd like us to first look at. And this is a little bit of a recap again of what we talked about yesterday with translating functions vertically and horizontally. So what I would like for you to do is to graph the function f of x equals negative absolute value of x plus 3 on the set of axes below. You're going to need to create a symmetric table of values for the absolute value function. Now be careful here. This is a reminder from yesterday's lesson. With absolute value functions, you need to create the symmetric table because a lot of times students will forget and create a line because they see a pattern. So say they see a pattern and it continues, but maybe it changes right here, and then there's the turning point and it goes in the other direction. So you want to just be consistent and make sure that you find the axis of symmetry and then plot values to the left and to the right of that. So we want to ensure that we are creating a V shape. Alright, so that's just a little bit of a reminder from yesterday. So why don't you get started with that? Here's where you should probably pause the video because the solution is coming up next. Alright, how did we do? So here I have my graph of the function. We have a V shape and it's facing downwards. And here I have my x and y values listed. I just decided to go from -3 to +3. Okay, so you could have done more values, and this is what my function looked like. Again, you can just go into your graphing calculator and just graph this and then jot down the points over here as I did. Alright, so let's actually delve into today's lesson on reflecting, stretching, and compressing functions. We're going to look at absolute value and quadratics as we did yesterday. Are you ready? Here we go. So, I have a GeoGebra activity for you. Now, traditionally, if you were in class today, I would have had you working in groups of 2. So 2 of you would be working on this together. And let me just go over a little bit of instruction here. So, with the person sitting next to you, obviously if you're at home watching this, you're going to be working on this by yourself. But I had the students spend 10 minutes coming up with conclusions about what they could draw on the parent function. And when they were done, they called me over. So what you're about to do is we're going to check out this GeoGebra activity that I created for you. So the whole purpose of today's lesson is to draw conclusions of what you can make when I adjust the slider over here. This slider is essentially just changing the A value. So that's just the coefficient right here. So here's A. And then we have 1. So A is equivalent to 1 right now, as you can see up here by our slider. Alright, and I'm just adjusting A to see what happens with the function. So the blue, as you can see, is the parent function. When I move the slider, that's our transformed function. Okay, so let me just bring it back to 1. Alright, so I have A at 1. This is just our standard parent function. But let's see what happens when I increase A. So maybe I'll make A 2. Alright, so let's make A 2. Okay, A is at 2. What do you notice happened to this transformed function in comparison to the parent function? Not sure yet? Let's bump that number up a little higher then. Let's maybe make it 8. Okay, do we see any drastic changes? Hopefully what you're able to conclude here is that as I increased a, that pink function, our transformed function, actually became narrower. So let's see what happens when I decrease my a value. So I'm going to bring it back to 1. Alright, back to the parent function. Let's decrease a. I'm going to bring it down to 1/2. Okay, what do you notice? Well, definitely didn't get narrower. Now it appears to be wider now. Okay, let's keep going. Let's bring it down to 0. Okay, well now we have a 0 slope here, a horizontal line. There is no actual parabolic function because anything times 0 is just 0. Let's continue to decrease a. Now I have a at -1/2. Alright, well, it now has negative y values. It has negative y values, and it basically flipped upside down. Okay, let's keep this in mind. So, flipped upside down, and now it's wider. What happens when a is -1? When a is -1, that actually looks, that is a mirror image. That's exactly a mirror image in the x-axis. Okay, so let's continue to decrease a. Let's see what happens. Let's keep going. So as I decrease a, it just gets narrower and narrower. And it's flipped upside down. Alright, so your job is to come up with some kind of generalization that we can make when the function is narrower, when the function is wider, and when the function is reflected in the x-axis. So that is your job, to come up with some kind of generalization of what's happening with a. So take a few minutes to think about that. What's happening with a? I'm going to bring it back to our parent function. Alright, so now again, if you were in class today, I would have divvied you up into pairs, and another group would have been working on the parent function of the absolute value. So the other group also would have spent 10 minutes doing this, and I'm going to show you this very briefly because I spent a decent amount of time showing you how to do this with the parabola. And now both of these GeoGebra files can be accessed on my website, so feel free to access these to practice with. Alright, so now I have my absolute value function. So again, it's set right now at a being 1, my parent function of the absolute value. And what your job is to do is, with both functions, totally up to you, is to see if you notice a pattern. So if I increase a, what happens? And then what happens when I decrease a? Okay, so again, that is for you to figure out, and I want you to spend some time thinking about it, so this is a better image for you to look at, okay? Alrighty, let's keep going. So what we also did in class was, after this activity was over, we then moved on to the lesson packet of the day. So first page, below are the graphs of the parent function f of x equals x squared. We have g of x equals 4x squared, and h of x equals 1/4 x squared. And you are to compare the functions of g of x and h of x to the graph of the parent function. So that parent function right here in the middle. Alright, so for the parent function, f of x equals x squared on the transformation of g of x equals ax squared. If the absolute value of a is greater than 1, well then the graph of g of x is blank than the graph of f of x. So when the absolute value of a is greater than 1. Okay, so if I look over here, 4 is clearly greater than 1, absolute value of 4. What happened? Look at this function, and look at this function. Any ideas? Narrower, yes. The graph became narrower. Awesome. Okay, now what happens when a is less than 1? So 1/4, right over here, that 1/4 is less than 1 we have over here. The graph became wider. You got it. Awesome. Let's keep going. So below are the graphs of the parent function, f of x equals x squared, and g of x equals negative x squared. And you are to compare the graph of g of x to the graph of the parent function. So here we were talking about this before. When we negated the function, it actually reflected in the x-axis. So in other words, the graph has been flipped upside down. It's another way for you to think about it. And then vertex form, we talked about this yesterday actually. If you recall, we take the opposite sign of what's inside the parentheses, so we would just have h, and we keep the sign that's outside of the parentheses, which would just be k. That's going to come into play in these following questions. And this is just a bit of a recap of what we talked about. You can take the time to pause the video if you would like to review this. So here are the questions that I have for you to work on your own. And what I would like you to do is actually describe the transformation of the parent function, f of x, to g of x, and also state the vertex. So if you would like, here would be a good time to pause the video and actually try these problems. Alright, and on to our solutions. Double check your work with mine. If you're having any problems with these, please come in and see me for extra help. There's extra help, as you know, every single day, 10th period, and I also have extra help during my free periods. And here is another 2 problems for you to work on. So take a few seconds or moments to read this over and then pause the video to find the solutions. Alright, and here are our answers. So just briefly looking at question 10, it asks for the equation of a parabola that has the same vertex as the parabola represented by y equals x squared, but is wider. Well, we already talked about this earlier. If we follow our rules, the absolute value of a, when it's less than 1, our function is going to be wider. So all I have to do is look for the coefficient that's in front of x squared and find out which one of these is less than 1. And choice 4 is our only answer. It's the only possible option. Now if you notice, answer choices 1 and 2, they have +2 and -2. I want to keep the vertex the same, so if I add 2 or subtract 2 to the function, well, the first one would be shifting the function up 2 units, and then the second one would be shifting the function down 2 units. I want the same vertex, so we leave the intercept alone. Alright, and then number 11 is very similar to question 10. It wants to know how the graph of the function y equals x squared plus 4x plus 3 is affected when the coefficient of x squared, so we have a 1 in front there, is changed to a smaller positive number. So again, we can follow that example from before. Change 1 to a half, as we have over here. Well, that half made the function wider, and it didn't change the y-intercept. So it has to be choice 2. Alright, take a look at questions 12 and 13 on your own. Alright, check your work. How did we do? Okay, so exit pass. I would like you to try these questions on your own. I did provide the solutions. However, I would still like you to attempt this by yourself. This is what I would have collected from you at the end of the period to gauge how you did with the material. So I would pause the video here. Okay, great. Hopefully we did all right with this. Again, this is just a summary of stretching, compressing, and reflecting quadratics. We had that nice little GeoGebra video to help us out. And you do have homework tonight, which can be found on my website. And there's the back. Alright, let's keep going. I do have some wrap-up questions that I just want to end with before concluding this video. Just a review of shifts, so kind of pertaining to yesterday's lesson. G of x equals x minus 3 squared. we would have that it shifted to the right 3 units. And then x squared plus 8, we would have that it was shifted up 8 units. And then I have both vertex here, here, and here. And some concluding questions that really pertains to the majority of today's lesson. Would pause the video here, and the solution is up and coming. Well, that concludes today's lesson. I hope this was helpful. Again, if you're struggling, you have questions, please come in and see me. You can access my GeoGebra file on my website. You can access the homework on my website. So I hope you have a better understanding of this. I will see you tomorrow in class.